When upgrading a ground wire inside Romex cable, you can run a number 4 ground wire alongside the number 8 ground wire inside the existing Romex cable. This method involves several steps. Firstly, remove the outer jacket of the Romex cable at both ends to access the internal wires. Secondly, carefully pull out the number 8 ground wire from the cable. This will create an empty space within the cable assembly. Thirdly, insert the number 4 ground wire into the now vacant space within the Romex cable. This new, larger ground wire will supplement the existing grounding system. Fourthly, at both ends of the cable, use a crimp connector or solder a wire nut connector to join the number 8 and number 4 ground wires together. This ensures electrical continuity between the old and new ground wires. Fifthly, we install the outer jacket of the Romex cable to protect the wires inside. Secure the ends with electrical tape to provide additional insulation and prevent moisture from entering the cable. This method is allowed by the National Electrical Code and offers a more cost-effective alternative to replacing the entire cable run. When performing this task, firstly, ensure that the wire connectors used are rated for the size and type of wires being connected. Using appropriately rated connectors is crucial for safety and code compliance. Secondly, make sure that all connections are tight and secure to prevent overheating and potential electrical hazards. Loose connections can create resistance, leading to heat buildup. Thirdly, it is recommended to have the modification inspected by a qualified electrician to ensure compliance with local code requirements and to verify the safety of the installation. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety. When dealing with electrical systems, it is important to consult the latest edition of the NEC and adhere to all applicable requirements. Grounding is a critical aspect of electrical safety. A properly installed grounding system provides a path for fault current to return to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to trip and to energize the circuit. This helps prevent electrical shock and reduces the risk of fire. The size of the ground wire is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum required size of the ground wire based on the ampacity of the circuit conductors. In this scenario, the inspector is requiring a number 4 ground wire, indicating that the initial number 8 ground wire was undersized for the circuit. Running a supplemental number 4 ground wire alongside the existing number 8 ground wire provides the necessary grounding capacity to meet code requirements. Romex cable, also known as non-metallic sheaths cable, is commonly used for residential wiring. It consists of 2 or more insulated conductors and a ground wire, all enclosed within a non-metallic jacket. When working with Romex cable, it is important to handle it carefully to avoid damaging the conductors or insulation. Avoid kinking or bending the cable sharply, as this can weaken the wires and lead to future problems. When making connections, use appropriate connectors that are designed for use with Romex cable. These connectors ensure a secure and reliable connection between the cable and the electrical device. When removing the outer jacket of the Romex cable, use a cable stripper or a utility knife to carefully slit the jacket without damaging the underlying conductors. Be sure to remove enough of the jacket to allow for easy access to the wires, but avoid removing too much, as this can expose the wires to damage. When splicing wires, use wire connectors that are appropriately sized for the wires being joined. Twist the wires together tightly before applying the connector and ensure that the connector is securely fastened. Avoid over-tightening the connector, as this can damage the wires. When running Romex cable through walls or ceilings, protect the cable from damage by using nail plates or other protective devices where the cable passes through studs or joists. This will prevent nails or screws from accidentally penetrating the cable and causing a short circuit. When installing Romex cable in damp or wet locations, use cable that is specifically rated for wet locations. This type of cable has a moisture-resistant jacket that protects the conductors from moisture damage. When working with electrical systems, always turn off the power to the circuit before beginning any work. This will help prevent electrical shock. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical hazards. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it is important to have it done correctly to ensure safety. The NEC is updated every 3 years, so it is important to stay up to date with the latest edition. The NEC contains a wealth of information on electrical safety and installation practices. It is a valuable resource for electricians, contractors, and homeowners. Grounding systems are designed to provide a low impedance path for fault current to flow back to the source. This allows overcurrent protective devices to quickly trip and to energize the circuit, preventing electrical shock and fire. Grounding systems typically consist of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel. The ground wire from each circuit is then connected to the grounding bus in the panel. The grounding bus is connected to the grounding electrode, providing a path for fault current to flow to ground. The size of the grounding electrode and the grounding wire is determined by the size of the service conductors. The NEC provides tables that specify the minimum required size of the grounding electrode and grounding wire based on the size of the service conductors. In addition to grounding, bonding is also an important aspect of electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a common electrical potential. This helps prevent voltage differences between metal parts, which can cause electrical shock. Bonding is typically accomplished by connecting all metal parts to the grounding bus in the electrical panel. This ensures that all metal parts are at the same electrical potential as the grounding electrode. The NEC requires that all metal parts of an electrical system be bonded together, including metal conduit, metal enclosures, and metal equipment. This helps ensure that the electrical system is safe and reliable. When working with electrical systems, it is important to follow all applicable codes and regulations. The NEC is the primary code that governs electrical installations in the United States. However, local jurisdictions may have additional codes and regulations that must be followed. It is important to check with your local building department to determine the applicable codes and regulations in your area. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure safety. Always turn off the power to the circuit before beginning any work. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work for you.